Yeah, so hi everyone, I'm Jeremy, and today I would like to talk about a project called JupyterLite, and this is going to be a mix of Jupyter, WebAssembly, and Python. So I'm currently working as a technical director at Quantstack, and at Quantstack we do scientific computing, so we are involved in projects such as Jupyter and also Mamba and the package management stories. So we maintain and contribute to many Jupyter projects. For example, JupyterLab, Jupyter widgets, JupyterLite, and Voila dashboard, and many others. So maybe you can meet us on GitHub as well. And this presentation will be about JupyterLite. So you might wonder, like, how is JupyterLite different compared to normal Jupyter? So I have a couple of cells in a notebook here, and I can execute them just like in normal Jupyter. So you might wonder, like, what's the difference? So I'm going to wait a little bit. So one of the main differences is that with Lite, it boots in a couple of seconds. So actually, here is the GitHub repo for this presentation. So this presentation is actually deployed to GitHub pages, and if you scroll down, you can actually, play with it at the same time or later. It will be available there. And if you look at the link here, it's something on github.io, and that means it's deployed on GitHub pages. So if I open this link, it actually gives me JupyterLab interface and just boot it really quickly. So that's one aspect of JupyterLite. Another thing is that there is actually a CLI that's called the JupyterLite package on PyPI. So if you go here, we actually publish a Python package, and this Python package is pretty much just a static site generator. So you can use this CLI to just create your own static website, just like you would do with something like Jekyll, for example. And in the end, you get something like you have all of the tools to create your own Jupyter website, and you can create your own in a couple of minutes. So there is a demo repo under the JupyterLite org. And it's actually a template. So if you go here and you click on this button, I will create one just to show you the flow. So here I could say my custom Jupyter website, and then create. What it's going to do is going to create your own repo from this template. And it's going to deploy the JupyterLite website on the GitHub pages. So one thing you might have to check is that, let me see, in actions here, you need to be able to write. So, but it depends on your default on GitHub, but normally they should do it. So it might take a couple of minutes. So I might come back to that later. But you see here that there is actually a build triggered. And after the build, there is the deploy. And once the deploy is finished, then you can access your website just like this. So in the end, you get a lightweight Jupyter frontend that runs entirely in a browser. So here we didn't have to set up any server. There was no terminal, no command line involved, no need to install Python or any other packages locally. It was just available right there in a browser. Which means that it's very easy to deploy. So we have documentation to show you like all of the different scenarios, and, the ways you can deploy JupyterLite on a bunch of providers. So there is also another website you can check. It's the one for the main JupyterLite repo. So this is where most of the development is happening, and this one also has some kind of nightly build in some way that we push to read the docs. So if you visit this URL, you will also get JupyterLite built from the tip of the main branch. So it's like very new things available there. So GitHub pages, GitLab pages, read the docs, but also other providers like Versal or Netlify that are usually like common places to put static websites for like front-end developers. So yeah, it's pretty easy to deploy in the end, because it's just, you just need a static website, a static server to serve static files. So a little bit of history. So this idea of having something like that is fully static, it's like a Jupyter environment, is not new. So JupyterLite is kind of a reboot of many attempts of doing this. So one of the first ones was Jive by Nick Bolveg, and Nick Bolveg is now a contributor to JupyterLite. He's done a lot of things for the project, and here we see that there was attempts of doing that with something called Python, so for running Python in a browser. Then I started to experiment a little bit with a minimal notebook UI based on the JupyterLab ecosystem and components. So the idea was to build something from scratch, from the bottom up, and try to make something like a new application, pretty much. So that gave this thing called P5 notebook, really specific to this JavaScript library called P5.js. But we also have other projects, and one of them is called Baston. And Baston is very similar to JupyterLite, but they use the classic notebook, so the Jupyter notebook as we know it, which is now deprecated, but it's still worth mentioning because they managed to get Baston in the schools. So in France, there is a project, and it kind of gives students this kind of environment, online environment, so they can learn programming and a bunch of things. So that's very great. And one more project called the Starboard. So it's not really Jupyter, but it's pretty nice. So you can mix different languages in the same notebook. It's a different approach, but still worth mentioning. And there is also Observable, which is like very native to the browser. It's maybe a bit more focused for JavaScript, but it's also a different paradigm. So it's more like reactive programming with this kind of notebooks. It's still interesting to keep that in mind. So back to JupyterLite. So with Lite you get JupyterLab and the Jupyter notebook interfaces. So that means, actually, you might have noticed that here we are in a notebook. So this is kind of a sneak preview of the next version of the classic notebook, which is going to be called Notebook V7. And this one is built entirely using JupyterLab components, and works with JupyterLite. So this is one of the interfaces, and the other one is the one we also saw briefly earlier, so JupyterLab. And here you get pretty much the usual things you would expect. So there are like files, you can go in different folders, you can open this notebook, for example, and it shows up here. So you have your running kernels. There's also the table of contents on the side. So just like JupyterLab in general, but there is also support for themes. So you can switch to another theme, you can switch back to this, just like in JupyterLab, and also support for other display languages. So here we are going to change the interface to French. Now I'm going to put it back to Chinese. No, I'm kidding, to English. So yeah, so this is just using the whole infrastructure that is already in place for JupyterLab, and JupyterLite is really just trying to make a good reuse of all of this. So we have there's a process which is crowdfunded for translations, and JupyterLite just consumes this, so just like JupyterLab. So that's a very low effort to have support for that as well. So you can also have code consoles. You can start a console here, to enter some code. What do we have? Yeah, and we have also support for the whole ecosystem of extensions for JupyterLab. And let's see, maybe one that could be interesting to look at is the JupyterLab tour. So this is kind of, it gives you a way to, for example, tell your users what the UI is. So it kind of gives you a tour of different things you have in JupyterLab. So this is an extension that is not part of JupyterLab, but was installed next to this deployment, so it's available. And there are just plenty of other extensions that just work also with JupyterLite, just like in JupyterLab. All right, so yeah, like I was saying, just JupyterLite is just standing on the shoulders of giants. So it's really built like from the ground up. So we just kind of, it's like a Lego game. You can put all of the components together and make this application. And the cool thing about Jupyter is that it's more than just interfaces. There's like standards and protocols. So the kernels that you interact with in this interface, they kind of follow the same protocol. So it's just the same, which means that we can reuse a lot of different things. So like IPython also works, the other extensions, and then we have libraries like bqplot and matplotlib and many others. XUS, which is another ecosystem of kernels built in C++, is also compatible with this. And then we have PyData. So I'm going to talk about PyData right after. So we now are at the point where we wonder what is WebAssembly. So usually we talk about JupyterLite as a WASM-powered Jupyter running in the browser, and here is the kind of the page you can find on the Mozilla web docs about WebAssembly. So WebAssembly is a new type of code that runs in modern web browsers. Low-level assembly-like language, near-native performance, and provides languages such as C, C++, C#, Rust, and they can compile so they can run then on the web. And it's also designed to run alongside JavaScript. And all of this is very important because it just makes it possible to run Python in a browser. So JupyterLite ships by default with a kernel that is called PyData, and the PyData is built on top of PyData. So there is PyData, and PyData is just adding the layer to do all of the messaging. That is pretty much just the Jupyter protocol, and also adding support for IPython. And PyData is Python and the scientific stack compiled to WebAssembly. So they took CPython, which is mostly written in C, and a bit of Python, and added a couple of other packages like NumPy, Pandas, SymPy, and many others, and just compiled all of this to WebAssembly. So it means that here, if I just run these cells, you get Python 3.10. So this is using the latest stable PyData at the moment. And you get a bunch of cool things like, for example, error messages. So here you get this nice error printed here. There's also basic support for completions, the help, and also history. So a couple of magics, not all magics work, but a couple of them do. And then there are a couple of other interesting things that PyData exposes. So this line says that we want to import fetch, so the fetch method on the browser, from this thing called JS. And that means you can actually make HTTP request using the fetch method from the browser and inspect your results using the JSON viewer from JupyterLab. So yeah, so all the way. But that's quite useful because then you can really see, instead of having just a bunch of text printed there, we can reuse a lot of things that have already been done in this Jupyter ecosystem. So that means, for example, matplotlib works, so you can make plots. Also Plotly. So here, Plotly, they ship JupyterLab extension. So that means we can also reuse it there. So here you get interactive graphs running also in your browser. One thing that is worth mentioning is to be able to use these extra packages, we need to install them first at runtime using this thing called PyData. And PyData is a layer that JupyterLite adds on top of something called micropyp. And micropyp is provided by PyData, and it lets you kind of download the Python packages from PyPI and install them directly on the runtime. So here we install Altair, and then we can use Altair right here. You get the charts. You can also, just like in normal Jupyter, yeah, you can download them, export them. And many other displays are also supported, like GeoJSON. This one is pointing to us. Yeah. And also, so that was about static graphs and visualizations, but there is also support for widgets. So maybe you've heard about this thing called IPyWidgets. It gives you a set of controls like this. You can create sliders, for example, and then if you look at the value, update this, and then the value changes. But then you can do more fancy things, like linking the two. So if you update this, also updates this value here. So this is just normal IPyWidgets, and also works with JupyterLite because it also follows the same protocol. And there is also support for other custom widgets, and one of them is PQplot. PQplot lets you create charts that look like this. So you can change the color, change the fill, markers, create a new one, and then here you can update, kind of updates on the fly. So there is also IPyCanvas. IPyCanvas is an IPyWidget to use the HTML canvas to draw things on the screen. So here I'm just going to execute these cells, and this is creating a game of life in this thing here. So we're just going to draw the first iteration, and actually it's a good opportunity to showcase another extension that was made by the community. It's called Sticky Land, and gives you this kind of sticky thing on the right. So one thing you could do, for example, is to drag and drop here, collapse the input, and then run the cell after. So you can keep an eye on this thing running while doing some other things in your notebook. So you can even make the cell float. So it's like a window in a window, but it could be useful in some cases. So here we can close, and we can close this as well. Yeah, so this was a demo of the Python kernel using all of the libraries are already available out there. But I also wanted to mention another thing called XUS. So XUS is a C++ library for writing Jupyter kernels, and in fact there are actually already many kernels that are implemented with XUS. One of them is called XUS-Cling. And XUS-Cling is C++ in the notebook. It works, but not in JupyterLite. Unfortunately, not yet. But in normal Jupyter, it does, and it's quite remarkable. But there is another one, for Python. It's just an alternative to the default IPyKernel, and a couple of others for Lua and SQL. And the fun thing was that actually, since, if you remember, WebAssembly, it's like targets languages like C, C++. So C was useful for CPython, but C++ now is useful for XUS. So it means that actually you can compile XUS to WebAssembly, and that means bringing some kernels to the web. So there's a blog post here that you can check out if you want more details. And here I just wanted to showcase the one for SQL. So it was the kernel itself was created by Mariana, and then Thorsten Bayer took it and pretty much compiled it to WebAssembly. So you get a SQL also running in a browser with the Jupyter interface. So let me see if I can do this first. Yeah. And you can create a database, table, insert data, and then select the data. Insert more data, select, and then what is interesting is that you can actually use Vega. So SQLite, the XUS SQLite kernel has bindings for Vega, so you can do the same as we saw before. You can create charts from here, and static charts, you can download them. So it's just to showcase that it's not only about Python, it's also about other languages that can be compiled to WebAssembly and run on the web. And in fact, there are a couple of kernels already available for JupyterLite. Another one that is interesting, especially in the educational space, is Lua. And there is also the JavaScript kernel, P5. It's very similar to JavaScript. Wren, it's a bit more like of a toy kernel, and also the Echo kernel, which is more for testing. But yeah, so more kernels coming. A quick word about working with files. So here we saw that in JupyterLab we have a bunch of files here. So actually those files, they are coming from the server, so the HTTP server, and they are just static files. So you can create more files if you want. So here you can create a Markdown file, you can create a new notebook, and they will be showing up here in a file tree as well. But those will be saved in your browser. So here, if I open a new browser in incognito mode, for example, they won't be visible, but the others will be. So there is some kind of layering system right now that lets you combine data that you want to provide to your people, to your users from the start, and also let them create new files on demand. There's one caveat with this, is that it's not yet possible to access these files from a Python notebook. So that's something that is still a bit a work in progress. Well, it is technically possible. So from Python you can access the IndexedDB because that's something that's supported with the underlying tool called mscripton that takes the CPython and compiles it to WebAssembly. So PyData is using this tool. So with all of this, you can actually do it, but it's a bit clunky. So it's not as nice as doing with open and then pass a file name and work with the file. But should get there at some point, hopefully. So as an alternative, there is also another extension. So this is a JupyterLab extension. It's called File System Access. And another issue with this extension is that it's only compatible in Chromium-based browsers. So it's using an experimental browser API that is not standard yet. But what happens is that if you install it, so it works with JupyterLab. So you don't have to use it here with Lite. You can also work with Lab alone. So you have a different file browser right here, and you can open a folder. So for example, there is this one, maybe you know, it's called PyTunes. What happens here is that the browser will ask permission to read the local file system. So we say yes, and we can access the local files from this interface. So we are using a static website hosted on GitHub pages, but we access local files using this API. And that means you can open this TSV file as a spreadsheet, but you can also open other notebooks and work on them, execute them. It takes a while. Yeah, okay, maybe I should have taken, yeah, maybe this one, calm down. Yeah, so this is useful because then you can do work locally without having to upload them somewhere else. Because if you use the normal file browser, you can still upload files from here, but they will be uploaded to your browser local storage. So here it's just another alternative to let you work with files. Let's see. Yeah, and speaking of files, so one cool thing about the static deployment is that you can just go to here, for example, and let's say you want to share this file and this one. You can right-click, copy the shareable link, and then you can send that link to someone working with you. And then when they open that link, they get the two files open automatically. So that's quite useful if you share the same JupyterLite deployment. And then we start talking about the fun stuff. So again, since JupyterLite is just reusing as much as possible from all of the other projects that we already talked about, one thing that landed in JupyterLab recently is real-time collaboration. So if you're interested, you should check out the presentation by Kevin Jans, who worked with us to get that into the core JupyterLab. And he has a talk which is available on YouTube. And that means that you can also use it in JupyterLite. So there's, however, a difference. So it's not using the same kind of tech to synchronize messages and send messages across peers as in normal JupyterLab, but it's using something else called WebRTC. So it's going to be peer-to-peer. And it works, but there are a couple of issues, so we can try that. So I'm going to open, this is incognito now. This is Firefox, and I'm opening the same notebook. So here you see there is a difference compared to the things we saw before, is that there is this room appended to the URL. And if you change the room, then you can create some kind of isolations between users. And it's also displayed right here at the bottom. And here I can actually edit code, and we see that it's reflected on the other side. And when you execute, the output is also synced across peers. So you get kind of serverless real-time collaboration with a static website. So that's quite nice. But again, this is really reusing a lot of the work that's been done in the upstream projects. One other cool thing with JupyterLite is that there is some support for offline mode. So actually, there are a lot of configuration you can do. It's all detailed in the docs. You can pre-download all of the Python packages you need into a folder in archive. You can also download the whole PyData. It's going to be big. It's 150 megs, I think, if you take everything. But then you can put all of this together and put it on a USB stick, and then you can work from that. So in some cases, for example, if you are on a plane, you can still work. So that could be useful. And a quick word about how this works under the hood. So there is a server, but not a real server. It's a server that runs in a browser. So here on the left side, we have the JupyterLab and the Jupyter Notebook interfaces. And on the right side, we have the Jupyter server. So it's a very simplified server, but it does the job at handling the resources, the kernels, the content, all of this. And it's also using this framework called Lumino, which is also used by JupyterLab. And Lumino has a plugin system, and that means that every kind of components can be isolated in its own plugin. So here we have a plugin for contents, kernels, and the settings, and also each kernel is a plugin. So that gives a lot of flexibility. So if you want a deployment that only has one kernel, you can do it. If you want to make your own kernel, you can also develop it as a JupyterLab extension, because this is just reusing the same system. So here again, it's a lot of reuse from the ecosystem. So with this, we decided to think about what could be done more than just offering notebook interfaces. So we think that yeah, JupyterLite is very useful in, especially in the educational space. So with this kind of setup, you don't have to install Python locally. You don't have to deal with the terminal, because very often this is like the most complicated part in learning Python, is just to be able to install it. Although now it's a lot of improvements has been done, so it's already much better than before, but still. And if you have, for example, workshops and you want to teach something to someone, or you have like data science courses, you can just set up a quick website with all of the content. Another fun thing you can do with this is, for example, making games. And Thorsten wrote a blog post about Jupyter games. So he took this thing called Box2D, which is a C++ kind of physics engine, and then compiled it to WebAssembly. And let me see, maybe I can do a quick demo. Okay, yeah, or you can do it by yourself. So it's in here. And here, if you go to games, yeah, you can play billiard. So you can run this. Not sure if it's going to take some time to load. But yeah, so billiard. There's also World of Goo. This is also a rocket game where you land a rocket. So the whole idea is to kind of, especially for kids who want to learn Python or learn programming, if they have some environments like this. Okay, maybe it's okay. Maybe I picked the wrong one. But yeah, if they have some environment like this, it's much easier for them just to get into the fun part from the start. So that's it's kind of the goal with this project. And one thing that also happened with all of this in place is that there is JupyterLab, there is a Jupyter Notebook, but what if you could have something even simpler, like even more minimal? So there is now this thing called the REPL, which is shipped by default in JupyterLite, and you can embed it in your website. So if you take this code, iframe code, and just put it in your blog, for example, with Jekyll blog, you can get a Python console available, made available to your visitors. So just for the sake of it, I did this for my website, just to test if that works nicely or not. And you get this code console here, so you can run some code. So it's still using the same kind of components as we saw before. So this is just a JupyterLab console that has been put into its own application. So yeah, here it's taking a little while, still downloading the PyData assets, but once loaded, then it should be pretty fast. So there you go, Python, easy to embed Python REPL. And that kind of, when people started to see this, they wanted to have the same on their website, so we helped NumPy, maybe I can load this, it's already preloaded, numpy.org. So if you go there and you scroll down a little bit, there is also this REPL that you can use to test NumPy. So this is really nice, because then people who just want to play with it, check the API, can just copy paste the code and put it there, and you get NumPy in a browser. On the Jupyter website, there is this page called Try, and there are a lot of examples to try a lot of things using the Jupyter interface, and most of them are backed by a project called Binder. So it spins the server for you, but you can do a lot of things with it. But the problem is that recently the Binder project, they run into some issues with the funding. So this is where JupyterLite was useful, because when we want to demo the Jupyter interfaces, we don't need to have a full-blown server, and instead we can use the JupyterLite project, so that here, if you want to try JupyterLab, you can just click on that, and it gives you actually a JupyterLite. So it's not exactly the full-blown Jupyter, but it's enough, because the most important thing in that case is to just give you an overview of what you can do with such tools. So yeah, it had a huge impact on the cost. So they managed to cut down by I don't know, maybe 30% or so. So here we were just trading compute resources for static assets, so just a bit more bandwidth but less compute. And another one, so SymPy also joined the party recently, and actually it's just merged. It was just merged yesterday, so it's very new. And if you go to the SymPy website, so actually if you go here and you click on online shell, you also get this little REPL here, so you can try SymPy directly in your browser without having to install anything, and they provide a bunch of example code here, so you can put it in the REPL. And the interesting thing here is that with the Jupyter interface, all of this is rendering really nicely because it's using math jacks to render the math. So hopefully, this will finish. So you get some kind of output like this. So that's quite useful. Yeah, and if you want to do that on your own documentation, you can use a project called JupyterLite Sphinx. For example, IPyCanvas is using that. They embed a notebook, JupyterLite notebook, so you can play around with the library. More to come. Pandas is also going to do the same as in NumPy. The thing is, you can even think about doing that for many other languages because Jupyter is language agnostic. So just like we saw with SQL, you could also have repos for SQL. So yeah, maybe we'll see that happening soon. So of course there are a couple of limitations. So this is more suited for lighter workloads. So it's good for education, for example. If you want to install packages, you need to install them with micropip or piplite for now, at least. There is ongoing work to improve that part. Accessing files from Python kernel is still a bit clunky, as we discussed before. The initial download can be a bit big. It's like maybe 30 megs, but then the browser should already help a little bit by caching a lot of these static assets. And for PyData, so like running Python in the browser, there are also other limitations, like there is no real threading sub-process. It's possible in theory, but it's probably going to need some work. So sockets is also problematic. Not everything is implemented by Emscripten, the underlying tool that compiles to WebAssembly. So if you are interested in the future of Python in the web browser, so there is a keynote by Christian Heimes, a core Python developer, at the PyCon.de and PyData Berlin conference that was last month, and it should be available on YouTube soon. They started from this repo, and a couple of folks, they kind of worked in this repo and then upstreamed all of the patches to CPython, the core CPython repo. So now the CPython, like the tip of the main branch, compiles to WebAssembly, which is just great because then we don't need to have patches in PyData anymore. The PyData folks, they also did a talk at PyCon US, so you have the slides there if you want to check them. And there is also ongoing work on the whole package management story. And the idea here is to try to reuse a lot from Conda. So if you have already used Conda, it's very easy to install packages that are not Python. And for that, there is Torsten and Wolf who are working on something like this that would be also compatible with JupyterLite. And there is also some activity happening in the Python discourse about WebAssembly. So there's a new category that was created last week to talk about CPython, PyData, JupyterLite is also this new thing that was announced last week or 2 weeks ago at PyCon US called PyScript, which is also using PyData. So yeah, up next for JupyterLite, a lot of things. So this content management, a lot of improvements to do there. There is also like this new versions of JupyterLab and Notebook coming up, and JupyterLite is just able to reuse all of this almost out of the box. So we would just update that to the new packages and benefit from all of the improvements. And then there are improvements that can be done also to code completion. So the idea could be to run LSP server in a browser to have better completions. And finally, maybe have also some support for Voila. So Voila gives you like this kind of dashboarding system to take your notebook and transform it into a dashboard. And it would be cool if this could be also run in a browser automatically. So with this, just wanted to say thank you to all of you and also to all of the contributors.
Thank you, Jeremy. And we have some questions from the Slido. So I will just put somewhere. So the first one is about the performance of PyData. Does it support vectorization in NumPy, for instance?
I think so, but I'm not sure. You won't get the same performance as if you will be running it on your machine. So I think there is still a performance penalty. And vectorization, I think it's in the works. I'm not sure it's available yet. We need to double check. Yeah.
Okay. Another. I have to be closer. So another question is about compiling extensions in C, C++ side. So the docs describe how to compile those extensions. Are there any limitations or how it works?
Yeah, so I mean, a good place to start would be the PyData repo. So they have a bunch of recipes to compile packages that are C extensions, and they are available here. So some things will not work, as we saw, like threading, for example, multiprocessing, a bunch of things are not supported by the F-Scripton platform. So I think the best shot would be to try and see if you can make it compile or not. And yeah, I think the only way to add such packages to be able to use them on the web, for now at least, is to follow the PyData approach and use their build system, at least until we have this new mscript Forge infrastructure in place that would be able to reuse more things from Conda.
Thank you. So another question is about integration with Git or GitHub. So how do you connect changes from Jupyter to Git?
Yeah, so Git doesn't run in a browser, so unfortunately the Git extension for JupyterLab doesn't work with JupyterLite. So, but there are some options there. So for example, vscode.dev and github.dev, they also have support for working with GitHub at least. So one thing that could be interesting to look into, we haven't checked that yet, but would be to use another way of working with Git. So like running in a browser, for example, in JavaScript, and then use the GitHub API, for example, to commit changes, just like they do in github.dev.
Thank you. Another question is related to the packaging story. Is it possible to easily add your own Python package?
Yeah, if it's a pure Python package, you can just install it on the fly with micropip or piplite, like we saw here with all of the widgets and other libraries. If it's a more complicated package, then the best shot for now is to use this tooling that is in place. Again, it's the same kind of the same as what we discussed before. Until we have this Conda infrastructure in place, here the detail about how to create a PyData package. So yeah, so that would mean creating another kind of PyData distribution and then uploading it yourself to your web server and then using that from JupyterLite, which is all possible, but it's a bit more effort. Yeah.
Thank you. And we have last two questions. One of them is, do you think that one day you'll be able to run Conda Forge package in browser, including those depending on C++ beasts like GDAL?
Yeah, maybe. that I don't know. But one interesting thing is maybe I think I don't have it here. No. Oh well, never mind. Wolf, who is working also at Constack, just published something on Twitter today. I need to find it. So he was able to run Mamba, so micro Mamba in a browser. So that means like Mamba, if you don't know it, it's like Conda, but faster. So you can install packages using Mamba as well. And he was able to compile micro Mamba to WebAssembly, which means that you can run Mamba and the Mamba solver, which is using libsolve, directly in a browser. So maybe at some point we'll be able to have some, I don't know, like running Conda directly here and install packages like this and make them persist in some way. But this is all still, you know, very cutting edge. So a lot of unknowns.
Thank you. And the last one is the comparison between JupyterLite and standard Jupyter. What are the significant drawbacks?
Yeah, I think the drawbacks is mostly the limitations we have here. So, you know, it's running in a web browser. It's not as powerful as if you had your own server. But it's always a game of trade-offs in the end. So it depends on what you want to do. If you want a full-blown Jupyter and you know how to make it run on your machine, then you can just do it as normal. You might not need this, but if you want something for like newcomers who haven't done any programming before, then you can use something like this, like JupyterLite. But yeah, the main differences would be more about the limitations that we've seen here. Yeah.
Okay, thank you, Jeremy. So please, let's thank Jeremy.